Alright, for this video, we're going to go over Pythagorean identities. This is something that I definitely teach in class. This is new, it's brand new. It always takes you probably like a good week to really grasp this and to really understand it. And we prove these in class, so I'm not going to prove it here. These are the Pythagorean identities. This is the main one. Sine squared plus cosine squared equals 1. And they all revolve around from drawing a right triangle in the unit circle and using a squared plus b squared equals c squared. This is also real important. These are alternate forms of that first Pythagorean identity. 1 minus sine squared equals cosine squared, or 1 minus cosine squared equals sine squared. You're going to see these a lot. The other ones, right, I just have these listed. 1 plus tangent squared equals secant squared. You could also do, you could do something else. You could have like 1 minus secant squared. No, I don't want to do that. You could have, let's see here, you could rewrite it as secant squared minus 1 equals tangent squared. Like, that's another alternate form. Okay, and that's all I'm pretty much going to put down for that. For the third one, you have 1 plus cotangent squared equals cosecant squared. So what you really have to look at is the trig function. There's 2 trig functions and they're squared, and you also have a number 1 in it. So those should kind of stand out. When you see those 2 trig functions squared and you have the number 1, you're probably thinking, all right, it's going to be a Pythagorean identity. All right, now how can we use this? We're basically going to use it to simplify trig identities, which will probably be in like the next couple videos. I'm just going to do A, and then we'll use these a lot more, like I said, in the next videos that follow. For A, we have, if tangent of A is 2/5, we want to find the cosine. Now for this, I can't just use a reciprocal identity because cosine's not the reciprocal of it. So what we can use, I'm going to use this second Pythagorean identity because I have tangent. And I'm going to put 2/5 right into here for tangent squared. And if I'm going to solve for secant, the good thing about secant, it's the reciprocal of cosine. So if I use this, this is what I'm going to use 1 plus tangent squared of A equals secant squared of A. And I'm going to take this 2/5 and plug it in for that tangent squared. So it's going to be 1 plus 2/5 quantity squared equals secant squared of A. Right, and then I just want to solve for this. Let's get more space here. Okay, if I square the 2/5, it becomes 4 over 25 equals secant squared of A. If I add 1 and 4/25, well, you get 1 and 4/25, which is 29 over 25. That equals secant squared of A. Then to figure out what secant is, just take the square root of both sides, and you're going to get root 29 over the square root of 25. Square root of 25 is 5. So that's what secant of A equals. Now it says we want to find the cosine of A. Well, we can just take the reciprocal of secant. So cosine of A is just going to equal, I'm going to flip the fraction, so it's going to be 5 over root 29. Then I want to rationalize it, so I multiply top and bottom by root 29. And we wind up getting the cosine of A to equal 5 root 29. And then root 29 times root 29 is 29. So this is our answer. Okay, we won't do a whole lot of these problems. Really, the Pythagorean identities, we're going to use a lot of those for the back side of this worksheet.